Hi everyone, today we're going to match our higher order polynomials, what we've been working on before, to the actual graph today. And the skill is not going to take us too long to learn, but it does take a while to master because it's about looking at all these little fine little details and saying, hey, do I know what graph this is going to be? And we've actually learned several different tools for breaking down a large order polynomial, like something x to the fourth. We've learned about factoring using synthetic and long division to break down that problem so that we could figure out the roots. And then from the roots, we talked about the end behavior, the multiplicity, are we going to bounce or cross? So all this stuff is going to factor into what we're doing today. Okay, so let's go ahead and just jump into our IXL actually. And the IXL skill is going to be D.11. Oh, I wonder what it's in Chinese. That's not helpful. D.11. And the question is, as you can see here, it's just simply match the graph with a polynomial. You could just, guess, but that's not going to help you in the long run. And there are a couple of takeaways here that I want to make sure that we're catching. So let's go ahead and look at some characteristics of these. Now, first things first, I want you guys to notice the leading terms here. One is negative 2x squared and one is positive. So we're going to use the skills that we talked about before using end behavior to figure out which of these graphs are going to be it. Now, literally, you can probably know that this is positive, that's going to be this guy, and negative, and this is going to be this guy. Yes, you could guess that perfectly fine, and that's totally right. But I also want to spend this time reviewing the skills that we talked about before, looking at these leading coefficients. So if we put negative 2x squared, on the right side, that's going to be positive, right? Positive x's. And on the left side, it's going to be negative. I want you guys to practice this in your head or write it out, but on the right side it's going to be negative 2 times x, and on the right side the x's will both be positive, won't they? On the left side, my end behavior on the left side will be negative 2, and then we're going to have x times x, which is negative and negative. So I want you guys to take a look at what type of numbers will appear from this right side behavior. What's a negative times a positive times a positive? This gives us a negative. So it means that our graph is going to go toward negative infinity. It's going to head down. And of course, you look on the right side of this graph, it does head down. On the left side, we said we have a negative, negative, and negative, right? That leads us to be negative. So we're heading to negative infinity, and you can tell, hey, that's going down. Easy peasy. That's what we were going to pick anyways. But that's easy because this problem is pretty easy. I want to make sure you guys are okay with this skill for all our problems. The skill does not change. On the right side, let's say it's x squared. So on the right side, it's going to be what times what? Remember we said it's going to be positive on the right, and on the left, it's going to be negative. Negative and negative. So positive times positive is positive, so we know the graph is going to be up eventually. And negative, negative, which means it's going to be positive, so the graph will also be up on the left side. So you can see the end behavior of this graph is positive and positive. Okay, so let's go ahead and plug that in. We said it's going to be positive, and this one's going to be negative. Okay, let's see what happens. Easy peasy. Now this problem here gets a little bit more difficult. Looks a little bit more vicious, but we're going to add another skill onto this. So in case you do forget the leading term skill, maybe you can look at the Y-Intercept. So let's go ahead and do this again. Looking at my term x cubed, positive x cubed, okay? So on the right side, plus 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 means the right side is going to be positive. On the left side, negative, negative, negative means negative times negative times negative is going to be negative. Okay? So on the right side, we better go up, and on the left side, we better go down. My only choice is this guy over here. Now, I also want to give you guys another trick, and this is a trick that we probably remember from Algebra 1 and Algebra 2, is the Y-Intercept. If I had just plugged in 0, if I plugged in 0, 0, 0, isn't the only number left 215? That means this graph would shoot up, and does this graph shoot up to 215? Sure, it does. But careful, so does the other graph. The graph shoots up to 161. This graph would eventually hit 161. So the Y-intercept wasn't enough alone in this case because they were both headed up. So we had to know that end behavior, which helped us really figure out which way we were going. Okay, let's double check with this one over here. It's a negative x cubed, so that's going to be negative first, and then 1, 2, 3. On the right, sorry, on the left, negative 1, 2, 3. Why did I draw 3 parentheses? Remember, this is x cubed. So negative, 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 and positive, positive, positive on the right. So negative, 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 that's going to be a positive on the left, and negative, positive, positive, positive is going to be negative on the right. You can see this goes to positive infinity, and that goes to negative infinity. So it does match what graph we're talking about. Okay, let's make sure this does fit. Remember, we're using our end behavior models to make sure that we're picking the right one. Okay. So just one more time real quick, just to repeat the same problem. If I see x cubed, positive x cubed, I'm thinking positive, positive, positive on the right. Yes, that is going to positive on the right. Negative, negative, negative on the left. That is negative, right? So we are heading negative on the left. That does match up. My next problem over here, this is negative x cubed, okay? So it's going to be on the right, negative, positive, positive, positive. That's going to be still negative. That's why we went down. And negative, 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 x cubed, negative, negative, negative is a positive. That's where we're positive on the left. There's no guessing involved here. Okay, let's go ahead and move on to the next one. Now, this one is to the 4th power. So we're practicing our very similar skill we've been talking about before. Let's do this guy first. So on the right side, it's going to be negative, positive 1, 2, 3, 4, positive, positive, positive. This is going to be negative. Whoops. I don't know why I did that. This is going to be negative. So on the right side, the graph has to go down. Of the two options, you can see that this guy here goes down. It's going to be negative infinity. Double check on negative on the left side. Negative, 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 negative. 1, 2, 3, 4. This is positive. This is positive. But we still have a negative. This is still going to be negative, okay? On the left side, you do notice that this is negative on the left. And on our test practice, as well as on our homework, we were asked to say, would this be negative infinity or positive infinity? You can see this is headed down. So this graph does match this situation. On the right, let's look at x to the 4th. So that's positive, 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 positive. And on the left, negative, 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 negative. So the right's going to be positive. The left side's going to be also positive. As you can see, this goes up and up. Now, in this graph here, we can definitely see, because the y-intercepts are actually very small. Take a look at the y-intercepts just to double check here. This one is going to be 2 and this is negative 3. And you can see in the graph, this is my negative 3 and this here is my 2. So the y-intercept is also a super easy way for us to figure out at least one easy point on this graph. And just again, back up the fact that we chose the right graph. Okay, let's jump to something a little more difficult. Now, if you look at this version here, this one does give us, actually, no, let's refresh this for an easier one. Not easier one, but a different example. All right. Okay, so this problem here, you notice that we have one of our solutions factored out already. If you look at the first one, this is actually factored out already. So what value would make that go to 0? 2. So our x is equal to 2 with a multiplicity of 3. So if you look at this graph, does this have a solution at 2? Does this have a solution at 2? Of the two choices, which of these have a multiplicity of 3? Remember, multiplicity of 3 is odd. So is that a cross or a bounce? If it's odd, is that a cross or a bounce? This is a cross. So it does cross at negative 2. Not only does it cross negative 2, let's look at the end behavior. x cubed. A positive times a positive times positive stays positive. A negative times negative times negative stays negative. Oh my gosh, this matches everything that we're talking about. Look at the y-intercept. Y-intercept is -8, and the graph does hit -8. So this equation that's broken up for us, we could have graphed this ourselves. If I told you the our roots are x equals to 2 with a multiplicity of 3, you could have graphed at 1, 2, we have a multiplicity of 3. The end behavior says, hey, it's positive on the right, negative on the left, and the graph has to go through -8. Here's -8. We could have graphed the graph ourselves using these characteristics. And if we were in class, we would have focused a lot more on that. Okay, let's make sure the second one, x squared, so it looks like a parabola. Okay, positive x squared, so positive, positive, negative, negative. That's still going to be positive and positive on both sides. And the y-intercept is 3. Yep, this does match. So when they give us factor terms, the problem becomes a lot easier. Now, it gets a little harder because they want us to figure out which of the 4 solutions are going to match up now. Now, for this homework, you guys are asked to get up to 100% on the SMART score. Okay, so 100% means everything has to be right. One small step, and we're totally screwed, right? Okay, so I want to make sure we can figure out which of these 4 match which one. So first note is that I see x squared, x squared. What type of graphs are x squares? Those are parabolas. Positive, positive means a positive on the right. Negative, negative means a positive on the left. So this is up and up. Let's look down here. Up and up. Yes, this graph is up and up. Also check one more thing. What's the y-intercept? It's going to be -5. If I plug in 0 and 0, that's going to be -5. Does this graph cross through -5? Yes, it does. We have found x squared minus 2x minus 5. We found one answer. Our next one is a parabola again, but -x squared. So we do go through -x squared. So we're doing positive, positive with a negative in the front is a negative, and negative with our x and x, which is negative and negative, becomes a negative. So we are going down and down. That does match with the y-intercept at 7. That is 7. Yep, all our characteristics match. Now we have 2 more graphs. Let's take a look at the first one, negative x cubed, right? So negative, 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 negative. On the left side it would be a positive. So we got to go up on my left, and plus, 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 that would be positive times positive times negative. That would be negative on my right. Yep, this does match it. Our y-intercept is 1. Yes, it is 1. So we're double checking as much as we can, so as we don't want to make a mistake, and we want to make sure we pick the most accurate graph. All right, this next one here is, I see x cubed, so positive, positive, positive stays positive on the right. Yep. Negative, negative, negative stays negative on the left. Yep. And we have if I plug in 0 and 0, we have a y-intercept at 0. Yep. Now we figured out which of these graphs go to which, not because we're guessing, not because we're just hoping, but we're able to determine which is which based on our evidence. We said this was going to be negative and this is positive. All right. Now this next problem helps us a little bit because now they gave us the factors. Now let's take a look at the factors when I'm talking about the factors. If you look at my first answer here, what would make this go to 0 if x was what? Blank minus 5. What minus 5 would make that go to 0? So if x was 5 and we have a multiplicity of 3, we can look at all the graphs here. Which of these have x at 5, x at 5, x at 5, and x at 5, and x at 5? So we only have one of these options. Also, just to verify, with his x cubed positive, plus 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 is positive on the right, negative 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 is negative on the left. Yep. And our y-intercept would have been negative 125. going down, this looks like this graph would eventually hit probably 125. I don't know. It will hit something negative. So at least we use as many details as we can to verify this is the right person. Or I mean right graph. Our next graph, x squared, we know this is a parabola. Okay. Positive, positive on the right, negative, negative on the left is still positive and positive. Both sides are going to be positive pointing up. And our y-intercept is 3. Y-intercept is 3. And positive, positive. This guy here is positive, positive also. But the y-intercept is not 3. See? Y-intercept is not 3. So it looks like this would be this graph here. X squared plus 18x plus 81. This is factorable actually. It's going to be 9 times 9 is 81. 9 plus 9 is 18. So x plus 9 squared. So x would be negative 9. Take a look here. Negative 9 and a multiplicity of 2. So it does bounce. Oh, look, it bounced. X squared is positive, positive on the right. Negative, negative is positive on the left. So we do go up and up. And our y-intercept here was 81. Yeah, this graph looks like you eventually could hit 81. Okay, our last term, x cubed. So, oh wait, here's the next one right here. Oh, they factored it for us. I'm sorry. Looking here, we have a factored problem. Our x's are negative 2. And x is positive 1. Are you guys okay with negative 2 and positive 1? And looking at the graph here, look, negative 2, positive 1. Oh my gosh, that is perfect fit. Our y-intercept is negative 4. Bam, negative 4. Looks prettier every day. X cubed is positive, 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 stays positive on the right. Negative, 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 stays negative on the left. Yep. We have a multiplicity of 2 on negative 2, right? Look at that multiplicity of 2. We do bounce at negative 2. All our characteristics are here. Everything that we learned in the last 3 weeks of school. So we said this guy is for this one. X cubed was this one over here. X squared was this one, and one more. Yep. Okay. This one doesn't give us our breakdown of factors, but it does give us our y-intercepts and our end behavior. So let's go ahead and do this one. Okay, so let's take a look. If I pick the first problem, negative 2x to the fourth, okay, 2x to the fourth. So x to the fourth would be positive, 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 positive. So on the right side, we better be positive. And negative, 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 that means the left side is also positive. So which of these graphs are positive, positive? Look here, that's positive and positive. We have one more hint. The y-intercept is negative 2. And we're at negative 2 right here. Bam. This is probably going to be it. Let's look at the next problem. Negative x cubed, that's negative, positive, 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 stays negative on the right. And negative, 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 negative stays positive on the left. So which of these graphs are negative on the left side is up, but the right side is down? We're up on the left and right side is down. That looks like it might be it. The y-intercept is 16. Look, it looks like it probably will get to close to 16. Sure. So we found our second graph. Negative x squared, that's a downward facing parabola. It's probably going to be this guy here. Negative x squared. Just to verify the negative 9 here. Hey, look, take a look here. That's negative 9. And our x is negative fourth. Now, negative, positive, positive, positive. Since we have so many positives, but that doesn't matter. We care about our negatives. This is still negative. And you can see that's facing down. On my left side, negative, 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 negative. That's going to be positive and negative. Stays negative. That's why we're going down on my left. And that's it. Okay. So we're going to match our graphs. And submit. Okay. And that's it for today.